It was at this moment that he knew. He fucked up.
Well, that was electrifying. Let us see how I made it. The first step was to read through all of this. But by the power of video editing, what took me 3 fucking days to understand, I will explain it to you in less than 3 minutes. Okay, just so that all of us are on the same level, I will give a brief rundown of how a random encounter on a JRPG works and the subsequent turn-based battle system. This rundown will be based on the player's perspective, following which we will deep dive into the technicalities, that is the code behind it all. True to the word random, the battle triggers after the player takes a random amount of steps. Once the battle triggers, the corresponding actors, that is the player and the enemy, take their turn one after the another, performing their actions. These actions can range from anywhere like attacking the opposing actor, healing ourselves, or even running away from the battle itself. Understood? Great. Now let us see the technical part. For this part, we will be taking a reference from the Final Fantasy VI's random encounter algorithm. Why? Because A. This system or something very similar to this is used in pretty much all of the JRPGs, and B. This formula was readily available. Okay, so this is how it goes. Between each encounter, you keep the track of the number of steps the player has moved. You also generate a random number after each of the encounter. This random number ranges between the minimum and the maximum number of steps the player is allowed to take before a random battle occurs. So the system itself is pretty easy. As soon as the number of steps you have walked is greater than this random number you have generated, you start a random battle. And the parameters of your random battle are based on the current tiles your player is at. So for example, if you are on a grass tile, you would probably face, let's say, a rabbit or something. But let's say if you are on a desert tile, your enemy might most likely be a lizard or some sort. Great, so implementing this is pretty easy. First, we make a singleton class that will instantiate at the start of our game. In this class, let us call it Encounter Manager, will handle the random encounter algorithm for us. First, we make 3 variables. One to track the distance the player has traveled. Next, the random number that will range between the minimum and the maximum number of steps. And third, the length of the player's step, aka the stride. Next, we make an encounter handler function that will lay out our random encounter logic. This function will run every frame and take in the delta traveled by the player and the current tile's data as its parameter. Accumulate this distance delta into the variable that we created above, and when the number of steps the player has walked is greater than the random number that we generated above, we start our random encounter and reset the variables. To call this encounter handler function every frame, we create a signal in our player script which is emitted every frame after the player has walked. With this, our random encounter system should be working fine now. Now, to actually make the battle scene work, we create another scene, let's call it battle scene, which we will instantiate whenever we have to enter a random battle. To initialize this battle scene, we will fill its data, that is its background color and its enemies based on the current tile we are at. The data of the enemies and the background corresponding to the tile will be stored in another global scene called the data node. This scene will basically contain all of the metadata pertaining to our player, our enemy, and our background. So, for example, if we are on a grass tile, we would instantiate the battle scene with the grass texture background, and correspondingly, we will spawn in the slime enemy. Now, the actual turn-by-turn aspect of the battle is simulated via the help of state machine. Is this the most ideal solution ever? No. But is it robust enough to handle multiple enemies and stuff? Also, no. But is it easy to implement and works flawlessly for one-to-one encounters? Absolutely yes. If you want a deeper explanation of how a state machine works, please go watch any of my previous videos, but here is a basic rundown of how it works for our use case right here. Inside our battle scene, we first instantiate the state machine class, which is responsible for handling the transition between the various states. These states being the starting state, the player state, the enemy state, and ending state. At first, we are at our starting state. This state is actually responsible for setting up our battle scene. You know, the background, the enemy, etc. Following this, we go to our player state, wherein we wait for the player to give in the required commands. These commands, or rather action, being A. Attacking the enemy, B. Casting a spell on the enemy, C. Healing ourselves, and D. Running away from the battle. The code for these actions is actually present in the base state class, wherein we actually handle the logic behind them. Once the action has passed, we transition to our next state. These can either be the enemy state or the ending state. The former occurs when the enemy is still alive, the latter happening when either the enemy is dead or we have run away from the battle. Inside the enemy state, we randomly select one of the actions that it can perform, pass them, and depending on the situation, either go to the player state or to the ending state. The ending state is actually responsible for handling the ending logic of the battle, that is, we gain experience and levels if the enemy is dead, or the game is over when we are dead. Once the battle concludes, we are transported back to our original position that we were in before the battle started. And yeah, that is pretty much it about how I made my own JRPG combat system in a week, saving some other boring details like graphics, UI, etc. Yeah, going forward, I would be completing this project and making a full-fledged JRPG game, although a small one, in about a week, so you can expect a video during that time. So if you're interested in that, be sure to like the video and hit the subscribe button, and I'll see you next week. Okay, bye.